Welcome everyone. To get us started, we would like to share a little information about the National Center for Computer Science Education.
So the center is the home to some programs such as Mobile CSP, which some of you are taking this summer, CSAwesome, which some of you are taking, and we also have other programs. Another really big program or popular program that we have is our certificate in CS education. So we are a part of the College of St. Scholastica, which is housed in Duluth, Minnesota. And because the College of St. Scholastica is really one of the leaders in online education across the country, we're able and fortunate to offer the certificate in computer science education. So we have the ability, we offer the ability to take the Mobile CSP or CSAwesome professional developments and earn graduate credit for taking those. So if you are a teacher who is looking to earn a certificate in computer science education, that is something that you may be interested in. And if you have questions, feel free to reach out to us. We have also have other programs available at the center, and we invite you to learn more about the programs at css.edu/CSN. So at the center, we are a small, there's 7 of us, small team, but we're a dedicated team. And we have staff members that are involved with both Mobile CSP and CSAwesome. So the professional development that we offer at the National Center for Computer Science Education really focuses, whether you're on Mobile CSP or CSAwesome, on delivering CS content knowledge and helping teachers to understand more about computer science and programming. In Mobile CSP, we're doing MIT's App Inventor, and in CSAwesome, we do Java. So really heavy on the content knowledge and learning computer science. But we also try to bring in a lot of the pedagogical content knowledge as well. And so we talk about strategies that you can use to teach students and really create these opportunities in the classroom that are equitable opportunities for your students to learn and engage using some of these pedagogical techniques that we have available. We also provide curriculum materials. So in both cases, both Mobile CSP and CSAwesome are complete courses that are endorsed by the College Board, and we provide the student lessons and the teacher lesson plans for teachers when they complete the PD or as they're completing the PD. And we also offer this amazing opportunity to be mentored by an experienced teacher who's your PD facilitator and supports you throughout the entire summer PD as well as the academic year. So both PDs focus on having all of this content for you. And we try to structure it in a way that it's really all kind of wrapped together and put together for you. One of our goals at the center is inclusive excellence, and this includes both access and success for all students. So one thing that we try to do for access is we try to have, we ask that teachers try to have their class demographics match or mirror their school demographics. We realize that this can be a challenge in many cases, but we do try to provide the materials and the strategies for helping you do that. We also are trying to and strive to have all students be engaged in the learning process and in the classrooms, whether they're virtual or in person. And in order to help teachers prepare for this and be able to have inclusivity in their classrooms. So some of the things that we do in the PD is we try to make sure there's a safe space for discussion. There'll be topics that you will discuss throughout the PD within your groups, and we try to make sure that's a safe space for you to share your thoughts and experiences and practices with each other. We also want you to be aware of some of the equity issues that do exist in CS. If you're not already familiar with them, you'll learn about them, and then you'll be able to discuss them and share them with your groups. Also learning about those strategies that we mentioned about how to practice teaching in an equitable way in your classroom and what strategies might be effective for one group of students or maybe a particular set of students that you have in your class, such as supporting English learners in your classroom. And we try to make sure that we help you understand that it takes time to make change and that everyone is on a journey, that you are sort of on this journey together. It's not all going to happen in one summer or 1 year, and it's all about continued learning that you are experiencing.
So we'd like to share with you just some program-specific information, first about Mobile CSP and then about CSAwesome.
Computer science and we think programming. Well, programming is just one aspect of it, and we want to teach students about all these different areas. We'll talk about those in just a moment. What's different about the AP Computer Science Principles course is that the programming language is chosen by the teacher. So we know in AP CSA, it's Java, right? In CSP, you can choose. You can choose Python, Java, although it's not necessarily recommended. We do recommend in Mobile CSP, we use a blocks-based programming language, which is App Inventor. And we believe that's a really great introduction for students to kind of get the basics down in regards to programming. The course consists of a two-part assessment. So if our students are doing AP Computer Science Principles, they'll have the chance to take the written exam at the end of the year, typically in May, which will be 70 multiple choice questions that they take over 2 hours. But then they also do this assessment. It's called a through course assessment, where they actually get to create a project in the course that you kind of take class time to say, okay, students, you're going to work on your assessment right now. And they build a programming project. So in Mobile CSP, they would build a mobile app that meets the requirements for the College Board. I can share the link to the slides if you don't have them yet, but there are some things that we recommend that you look at in preparation to kind of get the background behind the course if you're not familiar, which is the website that the College Board has available, as well as the course and exam description. So you'll hear that a lot. You hear it in CSA as well if you've done CSA. So the CED, it's sort of like your best friend as you go through and you teach the course, and it's where you should go to look up questions. You know, if you were trying to find an answer to a question that you have, start there, right? You can also start with your PD group as well. There is a hard copy that you can get. Of course, the CED is available online for free, but you can order a hard copy for $35 from the College Board website, and we have the link for that as well. One thing that we recommend you start to look at now is the AP audit. So if you are teaching AP Computer Science Principles for the very first time, you want to take approximately 2 to 3 minutes to complete the audit process, which also includes informing your AP coordinator at your school that you're going to be teaching the course so that they have a heads up that you are going to submit the form and they'll be ready to submit that. We just want to give you the heads up about starting that process now because it's the summertime that's about to come and it may take a while before your coordinator approves that. We have videos available that we can share if you're not familiar with that process, and your PD facilitator, who will be Lucas, will also be able to help you if you have questions about doing that. When you're using Mobile CSP, we have an endorsed syllabus. So you don't have to create your own syllabus for the audit process. You just adopt our syllabus that's already in the system and say that you're going to use our curriculum to teach the course. So in terms of these big ideas that are taught in the course, there are 5 NCS principles, and those are creative development, data, algorithms of programming, computer systems and networks, and impact of computing. And so all of these big ideas are kind of like spread out through the entire course, and you really won't see them spelled out the way that they are. They're usually referred to by their acronyms or the letters. So CSN, for example, would be the computer systems and networks big idea. And so all of the big ideas are organized and spread out throughout the course. There's also these computational thinking practices that we want students to learn to be able to do these and have these skills before the end of the course. So these can be found in the CED, the course and exam description, where they're all listed and kind of color-coded by skill that the students can can or they will be able to do by the end of the course as they're learning and going through the curriculum. So you'll get more practice with those. Just kind of keep in your mind that there's 5 big ideas and be familiar with what those big ideas are. So to give you an example of how it breaks down even further, and you'll learn more about this in the PD, is it starts out with this big idea. And each big idea, this one in this example is Algorithms and Programming, or AAP, it's then going down to some enduring understanding that students need to have, which is further broken down into a learning objective. And for every learning objective, it goes further down into what is called an essential knowledge statement. So you'll be covering all of these essential knowledge statements by using the Mobile CSP curriculum with your students. And the learning objectives, you'll notice they have those colors. Those are from those skills that were back here, right? So each learning objective is paired to a skill. So it's saying once they learn how to do those things, that's a skill that they will have, but also that's a piece of knowledge, in particular, a specific piece of knowledge that they will know, and they're tested on those on the written exam. So again, you'll work with this framework throughout the PD and learn the structure a little bit more. And in terms of mobile CSP, right, you probably know by now, our focus is mobile computing. Students are using MIT App Inventor, as I mentioned, building socially useful apps. We really focus on having students build something that's meaningful and solving a problem for their community. We find that that approach helps get them engaged in the course. And then we also have a really big project-based focus. So at several points throughout the curriculum, students are asked to do these larger projects, such as the create task, which they submit to the College Board. And there will be all other small projects, which will require collaboration and being creative and having these ideas that they're going to communicate. So another big part, besides the programming part and the emphasis on the mobile computing topics, is our writing and communication. Students generally keep a Google Sites portfolio of all of their work throughout the course as they go through, and it becomes like their digital notebook, and where they're able to communicate to their peers and to their instructor and others too, if they wish, the things that they've been doing and learning in the course. If you're interested and you want to watch, there's a nice little video that was made of showing the inside of what a mobile CSP classroom might look like in the days when we're definitely in person. You can take a look of what that would be like. You'll notice in the pictures too that students have tablets. It's recommended that you get some tablets or devices for them to use to make that tangible, but students can use their own devices, right? I have my own cell phone. I remember when I first used App Inventor, I loved the idea of being able to take my own device and put my app ID on there and take it with me outside of the classroom. There's also the emulator, which we'll be able to talk about with Lucas a little bit more about how the structure will be and what technology you will need to get set up in your classroom in order to be able to do this with your students. So you'll kind of have the option of doing devices or using the emulator on the computer. Our framework overall, again, pulling from the National Center for Computer Science Education, we have inclusive excellence is at the top of our list. We really want all students to be able to access and be successful in computer science, right? So there's lots of ways that we try to do engagement in the course besides just the mobile apps. There's other activities that we do, whether they're on the computer or off the computer, which would be unplugged lessons. Different types of collaboration that we do, really trying to keep in mind being inclusive for all. And one of the things we're actually doing this summer is we're working on putting in more supports for English learners into the curriculum. So that's something that you'll start to see. Another big focus is mobile computing. So again, all getting the students' attention from building all of the mobile apps that we have, lots of tutorials and creative projects where they're learning the basics of programming and the impact of computer science from the lens of mobile computing. And then we really want to promote this idea of authentic learning. So like I said, students are using real world problems in their community as ideas and inspiration for the projects that they're going to create in the classroom. and then having their projects resemble what the real world work environment will look like, which is including collaboration and many different voices into the experience that they're having. If you haven't seen it yet, you'll be using MIT App Inventor, the block-based programming language. This is a quick preview. This is the first app that students build in the course, and you too will build it this summer. It's called I Have a Dream, and it focuses on playing the famous speeches of Dr. Martin Luther King and Malcolm X. And it's all done with the click of a button, which you can see here. If you do have a computer science background, you may recognize that there's an if-else statement here. So students are introduced to this selection and sequence are some keywords that you'll be learning about, all while using these visual blocks that they're piecing together. And App Inventor, happy to say, is now available on both Android and iOS. That was a challenge for quite a while. So if you have an Android or an iOS device, you can use either one. And again, I recommend that you use your own device that you have so you can understand how that technology works as you're going through the course. So why Mobile CSP? Well, we are really trying to engage students at the high school level. We know that students are living with their devices on a daily basis. We want to introduce them to computer science early by engaging them and learning about something that they're constantly using. And understanding with that video at the beginning today, we were watching a while ago about how computing impacts so many different areas in every aspect of our lives that we want them to see those and make those connections about why computer science is important and start doing that early, which is, high school is really great. We're aimed at the high school level, but we do realize we have middle school students and teachers that are using our curriculum too. So while we aim for high school, we do try to get into the middle school level as well. You may have chosen us because you know that we have the fully developed and endorsed curriculum. So we have both our student lesson materials and teacher lesson plans available, assessments available, a teacher dashboard will be available. I think Alexis is doing that. We also have multiple formats available, so AP, non-AP, or concurrent enrollment, and thinking about, again, about visually using a blocks language to help you with learning computer science.
Do you want me to keep the breakout rooms open for a few more minutes?
Yeah, just a bit more, almost there. So a course overview that we have is getting started. We have preview and setup. So I'll say, I won't read it all, but we have units 1 through 9. The main pieces of the curriculum are really units 1 through 7, with 8 being some prep, extra prep that students can do, and 9 being for after the AP exam. You can see we have the AP Create practice and the official one that's there. We also have a written project that they can do, which is called the Explore project. It's not required anymore, but students can do that. You can see we have the midterm exam that comes between unit 4 and 5, and then a final exam at the end. So just give you some sense of the structure, and then as well as when you read these units, the titles of the units, you should see that, oh, it's not really one topic, right? It's not that only one unit focuses on programming. Programming is all throughout our entire curriculum and spiraled in with all of the other 4 big ideas that are in the framework. All of our classes are done in 45-minute classes, so that may change depending on whether you do 90-minute classes. You may be doing 2 lessons in one, but for the most part, 45-minute classes, and there's a curriculum overview document that a lot of teachers like to use to see what that looks like and the layout of how much time each lesson will take them to complete. So all of this is provided for you. Okay? Again, just reiterating, everything is spiraled, right? It's not that one unit covers just one big idea. All of these big ideas, the 5 of them, are spiraled throughout the entire curriculum. So students are constantly building and revisiting on each of those big ideas and skills that they're learning in class. So this again is a reminder to review that in the CED with Lucas in that this week. We'll talk about more about these practices and skills and learn a little bit more about what your students will be learning in the class. So here's the fun part for you all. If you haven't heard yet, Mobile CSP is moving to Runestone. And so currently, if you wanted to see the Mobile CSP course, you could go to course.mobilecsp.org or teach.mobilecsp.org. So you have access to the current sites that are available there. However, by the time your PD starts, the hope is that we will have the Runestone version up and running, and you'll be able to access the course on Runestone. So while I invite you to look at kind of the differences in the site, so there's a student site, blue toolbar, teacher site, green toolbar, and get familiar with the structure of the course, just know that we're going to end up having you more than likely switch over. We're going to have you using the Runestone platform this summer once it's ready. But in case you wanted to take a look, you're welcome to take a look. It will be the same idea. There'll be a student course and a teacher course, but on Runestone. And the teacher dashboard has really good reviews, so you'll be able to set that up as well.
Let's listen in on a demo of MIT App Inventor.
Okay, this is MIT App Inventor, and it is really a nice interface that splits being able to design the user interface of a mobile app and then the programming as well. And it really is nice, I think, because it's where students can focus on learning the logic rather than the syntax. It really gets rid of this, almost gets rid of completely all of the possible syntax errors that can be made when programming. And so what I just wanted to show you here was how this works. So this is the designer view for designing the UI. Everything is drag and drop. So let's say we wanted to add a button. I can drag a button from the left side where all my components are. There's different windows or different drawers that are here that have things from text to speech, sound players, cameras, camera recorders. There's drawing and animation ability, maps, sensors, and there are also social, so you can do texting, although now storage has databases that you can connect to, and there's some other experimental things as well. So there's lots of options that you can choose from here. And once I've added a component, like a button, I can see in this sort of section here, what are all the things that I've added? I can rename them. That was terrible. And then on the right-hand side, these are properties. So every component has its own properties. We can change the background color of the button. Let's do something lighter. We can change the font size, make the font bold or italics. We can change the height and width of the button. We can put an image on the button. We can change the text, so say click me. And change the text color. So I'm actually going to display a label here. Labels are usually good for text. We'll put nothing in it for now. And I want to add a second label that will pick our random person in a second. So you can see you can add lots of things, change the layout. I didn't really want to do this. I'm not really paying attention to color schemes here, but we can do background color. Do like a light pink, okay? Lots of things. You can be as creative as you would like to add items in here. The other big part of this is what's called the blocks editor. So up in the top right-hand corner, there's 2 toggle buttons to toggle in between this blocks editor. The blocks editor is the workspace with all of the blocks that can be used to create the program code for the app. So there's lots of things here. And as you're teaching the course, you can teach students about the basic components and principles of programming, and then they can find those blocks. Notice for each of the components that I added, there's also particular blocks that go along with those as well. What I want to do here is I'm going to create a list, which is a variable. Make a list. And I can add items, whether it's text or numbers or other lists as well, to my list. So I'm going to do this one here. And I'm going to call this, these are our names. I'll put mine in first. Okay. All right, so we have a list of data. It's our names. When I click a button, and typically in App Inventor, when the way you speak, if you can talk out what you want to do, you can make the blocks do what you're saying. So when I click the button, I want from my list, so I went to list. The list I want is my names list. And where do I want to put that random item? I'm going to put it in my second label. And in my first label, just for kind of like effect, I am going to the built-in emulator in MIT App Inventor does take some setting up this file that you would have to install. I'm hoping that everybody has either an Android device or and they'll be able to use. All right, so if I go to the designer and whoops, I zoom in my way. I'm going to choose a light. See how the emulator updated? So sort of those live changes are happening. So let's see, hopefully I did this right. I'm going to go ahead and click me. There we are. Mark, you are the lucky winner. I don't know what you've won yet, but you are the person that was randomly selected from our list. But you can see how it displays the content of the list because we asked it to do that. And we have one random selection that was done. Let's see. And you can keep clicking. Completely random. Sometimes it's same name twice, which happens with randomness. Okay, so that is a preview of App Inventor.
We just want to cover with you some specifics about the CSAwesome PD program. First, just a reminder that the CSAwesome curriculum and professional development are endorsed by the College Board. That is, we are an improved curriculum and PD provider for AP CSA, and you can take this professional development in lieu of completing and participating in an AP Summer Institute. However, participating in a Summer Institute subsequently after completing the PD is definitely recommended, as the experience is a really valuable experience for you. So the goals for this particular breakout session, we're going to show you how to access important links and information to allow you to be successful in the PD this summer. We're going to help you to understand some of the PD procedures and expectations for the PD. And we're going to access some of the CSAwesome curriculum and the AP CSA framework and try to understand a little bit about what the AP CSA framework consists of. And you'll definitely learn a lot more about that in the summer time. So what is the AP Computer Science A course? By now you know that it is a College Board advanced placement course that is about introducing students to programming with an introduction to Java programming specifically. Students who take the course prepare to complete an exam later in the year, typically around the May month. And the exam consists of two parts. There's a written exam portion that is consisting of 40 multiple choice questions. It takes about 90 minutes for the students. And then 4 free response questions, also known as FRQs. And students have 90 minutes to complete that portion of the written exam. During the course, students also complete 20 hours of required lab time. And it's really important that you as a instructor of AP CSA understand what the course entails. And one way that you can become familiar with that before you start the PD is by viewing the College Board's website on AP CSA, which we provide the links to, as well as having readily available the link to the course and exam description, or the CED as it's known. The CED is basically your best friend as you go through the course and you teach the course to your students. When you have questions, you can seek the answers in the CED as well as reach out to your PD Google group and your facilitator. We also recommend checking out the course at a glance that's available from the College Board. This will really help you give you sort of this overview of what AP CSA entails. We also recommend, as of today, starting the AP audit process. And on CSAwesome, we have some videos available to help you if you've never done that process before. It's a good thing to get started on that now, so that way you can give your AP coordinator the time to be able to review the materials and approve them. So that way you have access over the summer. So we definitely recommend getting started with that AP audit process. So in terms of the course framework and what AP CSA consists of, we want you to think spiraling. So AP Computer Science A, or AP CSA, consists of 4 big ideas. These big ideas are the content that students will learn, and they all revolve around modularity, variables, control, and impact of computing. And as you see, each one of those big ideas is represented by a code there, mod, var, con, and IOC. And you're going to see those referred to quite a bit throughout the course. And you want to be comfortable with what those stand for. The framework also consists of computational thinking practices. So these are the practices that students will learn how to do. And there are 5 of those that we will work on throughout the professional development. And so those consist of program design and algorithm development, code logic, code implementation, code testing, and code documentation. As part of those computational thinking practices, there are skills that you will learn and that students will learn. And those particular skills are practiced and learned throughout the CSAwesome course. So CSAwesome specifically, our framework and what we focus on, while also focusing on the AP CSA framework, we're focusing on inclusive excellence, which we talked about earlier in the orientation. It's a huge goal of the center is to be inclusive of all students and success for all students in computer science. But in CSAwesome in particular, we also focus on creativity and collaboration, as well as using an interactive ebook. CSAwesome is hosted on the Runestone Academy ebook platform, and together all of these things we believe are specifically designed to support teachers and students who are transitioning from computer science principles to computer science A or CSA. So a very high-level overview of what the curriculum looks like. In the summer PD, we will cover units 1 through 6. And this slide gives you a breakdown of approximately how many days you will spend on each of the units in the academic year with your students. And this is all based on 45-minute class periods. So the days you see here that you would approximately spend on each unit is based on 45-minute class periods that you may have. And we have a pacing guide that we have that you can use to help make sure that you're staying on track to make it through all of the material during the academic year. And now let's hear from my colleague Beryl Hoffman, one of the curriculum developers for CSAwesome, for an introduction and demo.
CSAwesome is a free AP CSA curriculum, is officially endorsed by the College Board as a curriculum and as a PD provider, and it teaches Java coding in an interactive ebook where scaffolding and the transition from CSP to CSA is supported. And we also provide teacher lesson plans with extra resources. Let's check out some of the important links. To get to the curriculum, your students can type in course.csawesome.org, and it will be redirected to the Runestone site, which is a server that has a lot of free books on it, including CSAwesome. Another site, an important link, is CSAwesome.org for teachers. And from there too, you can get to the curriculum with this first link. But here you will find all the teacher lesson plans, the resources, professional development information, and an instructor guide to Runestone. To get to the lesson plans, you have to be a member of the Teaching CSAwesome forum. So make sure that you join that to have access to these. It is also free. So once you have access, you'll be able to select a unit, and every single lesson has teacher developed lesson plans for it, which you can just access right here, or you can go to your Google Drive and click on Shared Drives and get to the CSAwesome Drive that way with the account that you're registered with for the Teaching CSAwesome forum. So you can get to the lesson plans this way as well. So going back to the curriculum, it's organized in 10 units, as we can see here. And this follows the College Board CSA guidelines. So every unit has all the lessons that the College Board requires, and each lesson meets all the learning objectives that are required. There's also a lot of practice units with practice FRQs and multiple choice questions and so on. We do have a pacing guide here and the syllabus and the solutions that will also help you to pace through this curriculum. So let's take a look at the curriculum and the curriculum design. Let's go to Unit 1. And the first lesson here, Why Programming, Why Java. And you'll see that this is an interactive ebook for the students where they're given a little bit of text to explain what they're supposed to do, and then they can run code right in the book. So here I ran the code and I see the output below, and I can change it and run it again and see it again. If I come back to this page or refresh it, there's a load history button, and I can go back and see all my changes from before and see what kind of changes I did in the book. If you're logged in, you can, the system will save all your results. And as a teacher, you can create your own course so that instead of CSAwesome here, you'll have your own course name, and you'll have your students join that course, and they'll be able to save all their work in your course, and you'll be able to see all their progress and what they did. Other than these active code problems, there are also what's called parsons problems or mixed up code problems. And this is a great transition from block-based programming to text-based programming. And this was, a lot of these were developed by Barb Erickson, and this was her research area to show that these parson problems were very effective in teaching. And this book, the CSAwesome materials, are based on Barb Erickson's Java review course on Runestone, which is also linked in the AP CSA CED. But CSAwesome has taken that material and enhanced it and made sure that it meets all the College Board requirements as a full curriculum. So when you drag and drop the code blocks here, you can check it, and if you make 3 mistakes, you can ask for some help. So it says click on help me, and when you do that, it will try to make the problem easier. So for example, here it's going to combine 2 blocks, so combine these 2 together, so it's a little bit easier now, and you can check it now. In this formative exercise, you will eventually get it right. There's also parsons problems with distractors like this, where pairs of blocks are shown. So for example, these 2 blocks where the only difference is a semicolon on the end. So the student has to pick one of them, the correct one. And the help me here will remove one of the distractors here. So in this way, they're learning the syntax of Java without having to type in and test everything, but they're learning that a semicolon really matters here. And then later on, this kind of scaffolding, they will have to put that into effect and notice things like, oh, it needs a closing quote, it needs a semicolon, and so on, and fix these errors. Other than these formative exercises, there's always some kind of challenge at the end. This one isn't that complex, but as they get more complex, we encourage people to work in pairs, students to work in pairs on this, and we try to make them collaborative and creative and open-ended. And we'll see some examples of that in a bit. So in the College Board curriculum, objects are introduced early in Unit 2, but just using objects, not writing the classes. Writing the classes are in Unit 5. So in CSAwesome, we do turtle designs, creative programming, in order to provide a bridge from something familiar to the Java syntax, which is new. So for example, here is some turtle code. If I run this one in Unit 2, and you'll see the turtle is moving because of this forward, turn left, and forward command. So students have seen things like this before, but now they're getting used to the Java syntax. How do you create an object, use the new keyword, how do you call this methods, that kind of syntax, and also learning all the vocabulary of object-oriented programming, things like attributes and methods and things like that. Here, some of the challenges are more open-ended and creative. So for example, in this lesson, at the end, the challenge is to design a turtle house, a house for your, oops, not this one, a house for your turtle. Here we go. And use a lot more complex coding with the turtle in order to do this. We also have scaffolded FRQ practice and scaffolded AP labs built in, and we're continuously adding more things. And we also try to present block code next to Java code so that that transition from CSP to CSA is supported. Let me show you one of the FRQs. So part of the FRQs is learning to read the problem and find different things. that you need to do. So here, for example, you need to figure out what instance variables you need to create here. So you can click on different things in here and check to see, oh, would this be an instance variable? Let me see. So I found 3 of them, but not all of them, so on. And so these are scaffolded with some questions, you know, some multiple choice questions, some brief coding, you know, how would you call the accessor method here, for example. So that scaffolding will lead them to finally writing the solution and being able to run it as well. Let's also take a look at the lesson plans, which we talked about before. So the lesson plans were created by CSA teachers, and they have a standard format with an overview, the learning objectives, the materials you need for this lesson. If the College Board recommended more than 1 day, we'll break it up for you and show you how you could break it up. And then we have some suggestions on how to use the curriculum. So maybe some kind of hook or motivation, how to break it up so that perhaps some of the code you show in class and have them do it together, and some of the code you have them work in pairs and perhaps work through, you know, the next 2 active codes in pairs and so on. And then usually some kind of group work as well, creative group work. And then in the lesson plans, there's always a section for differentiation, more practice and enrichment, some background knowledge. And in the background knowledge, often there's some videos if you need those, some teaching tips for the transition from CSP to CSA. What you should do in the AP classroom once you finish a certain lesson. There's also many extra materials that the teachers created for us. So there's lots of worksheets. So the FRQs require writing code. So it's good to have practice with that. So here, for example, they're given a toy class and they practice writing constructors for it. And these could be homework or they could be in-class assignments. So these are all extra materials that are not in the ebook, but extra to use in class. In terms of other instructor support, the teaching forum is great. It has lots of teachers who are willing to support one another and share resources. We provide the solutions file. And you can also build a custom course in Runestone, and we have help on how to do that and how to do grading as well. I wanted to end with the diversity challenge in CS, which I'm sure you've heard about. So one of the goals of CSAwesome is to change this. So here you'll see the total AP exam takers, and you'll see how the female students and the minority students in CSP, it goes down, but it goes down even further in CSA, and CSA is one of the most male skewed AP exams. So we want to definitely change this. So we also provide a lot of resources for inclusive and engaging pedagogy and trying to change some of the status quo in CS. And some of this is built into the curriculum, and some of this is just resources for you to use as you teach the course. Thank you, and I hope that you will enjoy CSAwesome.